Hello, Jonathan Hay here. Today I'll be sharing with you a recent project I've been working on. What I've created is a multi-purpose CSV reader which allows for programmable queries and light persistent editing. The scope of this program is relatively large, so I've included timestamps to key components of the program in the description to ensure that you can access the sections of my explanations which are most useful to you. The first thing that is vital to understanding how this program works is understanding each of the different individual components of the program. The main components I'll be covering will be how to read a CSV file into the program, how to make objects hold queries and data with any number of fields, then how to create different functions, sorts, and queries that operate on the data you load into your program, and how they work. Obviously, before we can actually do anything with the data, it needs to be loaded into our program, and before we can do that, we need to know what we're loading in. There are a couple ways we can do this. You can either just prompt the user for the name of the file, or the alternate method, and the one I prefer, is to detect all of the CSV files in a directory and give the user options based upon what the program finds. I've created a method to perform this task and load what it finds into a string array so the file names can be used later. This method creates a new file list in the location of the directory that is passed to it, then goes through all the files in the directory, finds how many CSV files there are, and their names. Moving back up to the top of the program, this is where we call this method, and then tell the user what choices they have. I would like to mention that the methods from the Safe Inputs class contain a variety of methods that I created specifically to safely take user input, and it is essentially a more advanced version of Java's scanner. So if you see Safe Inputs anywhere being called within this video and you're using it as a tutorial, you'll have to use Java's scanner or a variant of it in its place. Moving on, when the user makes a selection, it is saved as the file choice, and it will be the file that the program loads data from. Now the data can actually be loaded. First, a file reader and a buffered reader, which require the Java I/O import, are created. Then the program should read through the file and see how many lines it needs to load in, create an array of data containers based on the number of lines. Then it will split all of the titles, then the fields, into a data container where they are held within string arrays. Because of the time it takes for Java to print large amounts of data to the console, the user will also be warned if the file they chose is very large and recommended that their search is narrowed down before outputting. But before we get into how those searches, sorts, and outputting works, let's get back and look at what the data is being loaded into, those data containers I was talking about earlier. This object to hold data is pretty simple, really. It holds all of the data in an array of a size defined when the program reads in the file, and can return the data, set data values, as well as allow the data to be printed or not, depending on whether or not it meets the search requirements. Now that you can see how the data is stored, let's start doing things with it. The program now presents the user with options. They can alter the titles, which is straightforward, changing string values, add, remove, or apply queries, reset the searches, reload the file, or output data. I'd like now to discuss how the queries are created, deleted, and applied. To understand how to do that, first we have to look at the query object. This is another simple object for holding basic data. It holds the query type, the field it applies to, its name, and what it will prompt the user with when it's used, and if it's active or not. Just to clarify, this object does not have any methods to actually perform queries. It just redirects the main program to use other methods based on its type. If we now return to the main program, what I mean by this is when you create a query, it just asks the user what field they want to make a query for, then runs a method called checkFieldType, which I won't bother showing because of how simple it is, but essentially it tries to parse the data to a number, and if it can, then it returns that it is a number, and if not, it returns that it is a string. This is so the user can then be presented with options specific to that data type. For example, you wouldn't want to try to sort numbers alphabetically. Once the user has chosen the field, the createQuery method is called. It asks the user what type of query they want, what they want to call it, and what they want it to say when it is used. This is all stored in a query object array, which can dynamically change size as queries are added, Then, the title changes and queries are saved and updated using the Save Queries method. As seen here, this method writes all of the data regarding titles and queries to a file with the same name as the original file inputted, but with a .dat extension. So it can be read in the next time the same CSV file is loaded, so the queries and title changes will be persistent and linked to that file even if the program is closed, then run again. The load query method is almost functionally identical to reading in the main file, so I won't cover it to avoid redundancies. If the user chooses to remove a query, the user is prompted to select the one they want to remove. Then the query that is getting deleted is essentially sorted to the end of the array, then the array size is decreased. The queries and titles are then saved and updated the same as before, effectively deleting the chosen query. Now let's talk about actually applying all of these queries and sorts. It's really quite simple actually. The program just lists the names of all the available queries. Once the user chooses one, it outputs what the chosen prompt is, then calls a method according to the query type and sets the query as active. These queries include an ascending and descending numerical sort, which performs a simple bubble sort, a method that allows the user to search with a min, max, range, or specific number. This checks through each data container, and if it does not fit the parameters, its doesPrint value is set to false. Forward and reverse alphabetical sorts, which perform bubble sorts identical to the numerical ones, but instead compare alphabetically. And finally, a search for keywords which checks for the word the user inputted, and if it is not contained, the doesPrint value of the data container is set to false, just like in the number range query. Once the user wants to reset their queries, they simply choose this option, and all of the data containers are set to print again, and the queries other than sorts are deactivated. The user also may want to completely reset all the changes, including the sorts that were made, and this can be done by choosing to reload the file, which will just perform the whole loading process covered at the beginning again. The final function of the program is to output all of the data. To do this, it finds the max width of each field by calling checkGapSize. This function goes through an entire column of the dataset and finds the largest size word or number, then returns that size. First, the titles are printed and formatted by spacing the fields based on their gap size. Next, the same is done for each data container, except the program also checks if the doesPrint value is true. If it is true, this means that the entry fits the parameters of the applied queries and is printed. Now I would like to give a direct demonstration of the program as it functions to the user. So for the purpose of this demonstration, I will be primarily using realestate.csv. It is a CSV file which contains real estate information from Sacramento, and it consists of about 1,000 or slightly less entries. So now if we load this file, the file is found and queries are loaded. This is because I have previously used this file, so the query file, the realestate.dat, is also loaded, which has previous title changes and queries. So if I want to initially apply a query, for example, sort the houses by price, I can choose that sort right here, which I have made previously, and it will sort it ascending by price, give the percentage, and say it's sorted. Now, when I output the data, it will output it organized in ascending order for the price. So if we come over to the price field and scroll down, you will see that the price is ascending. Now, we can also apply various other queries that I've created to demonstrate just perhaps one or two more. Now, if I apply query or sort, search by city, and enter part of the name, this search is now applied and it notifies me that I am now searching by city, Sacramento. If I output the data once again, it will include all houses from Sacramento as well as West Sacramento because it includes that keyword. If I would like to refine my search further, for example, just in terms of city, what I can do is apply that same query once again, and input west. Now that search has been applied, and when I output the data again, you'll now see that there are only West Sacramento City being displayed. And if you see, it has now notified me in the active queries that in search by city, I am searching for the keywords SACR and West. If I want to reset all of these queries, once again, I can either reset just the actual searches, or I can reload the file completely. If I reload the file, you'll now see that if I output the data, it is once again exactly how it was when I initially loaded it, with no sorting whatsoever. I will now briefly bring you through creating a query. So I would like to create a new one, and perhaps I want street. Say I want to sort the streets alphabetically, but in reverse order. So now I choose that option, and I would like to name it Sort Streets Reverse Alpha. And I would like it to prompt the user that it is sorting. Now that I've done this, if I go to see all the current queries I have and try to apply it, I will now see Sort Streets Reverse Alpha. I can apply it, it will sort. I will output the data once again, and you will see that the cities have been sorted in reverse alphabetical order. The reason perhaps that this was not the best query or sort to make for the streets is because they include numbers, so it also includes those numerical values as ASCII values as it compares and sorts it alphabetically. So maybe that wasn't the best sort, so I want to change it up a little. So I remove that. It has saved. And now, when I once again view the queries that exist, that one no longer exists. So that just puts on display perhaps some basic functionality or things the user would want to do and how it's outputted. I would also like to show you exactly where the data file is stored. You will see within this specific project folder, there is realestate.dat as well as realestate.csv. This is the file I've read in to the program that I have been altering. And this is the file which contains all of the information about the altered titles, if they are altered, otherwise they will be default, what it reads from the original CSV file, as well as all of these different types of queries which I have created within the program from the user interface, containing the type, the field, the name, and the prompt. So I hope that just gives you some basic understanding of how you may use this program. That obviously did not include everything, but I believe it included some of the most important features. And I hope this has been helpful, and may your trains never derail.